How is sound converted to a digital signal? Today, we will explore how sound is converted into a digital signal. The sounds we commonly perceive are analog signals, consisting of vibrations in the air. Our ears can detect these vibrations as they oscillate at various frequencies and volumes, resulting in the recognizable tones and loudness we identify. So, how can these analog sound waves be transformed into digital sounds stored on computers and other storage devices? The conversion process involves pulse code modulation, PCM, which transforms sound into digital signals through three main steps: sampling, quantization, and encoding. Let's analyze this step by step. Number 1. Sampling. Picture the sound waveform as a continuous curve. To capture this curve, we must take measurements at specific intervals, a procedure known as sampling. A higher sampling frequency permits us to record more measurements, which captures more intricate details of the sound. In audio, we generally use a sampling frequency of 44.1 kHz, which means that 44,100 measurements are captured each second. This sampling frequency effectively reproduces sounds within the human ear's hearing range. Humans' hearing range is roughly 20 Hz to 20,000 Hz, and a sampling frequency of 44.1 kHz satisfies this criterion. Number 2. Quantizing. Once we have sampled the data, we obtain a series of points that reflect analog values. We must assign specific values to each point to transform these into digital signals that computers can understand. This process is akin to segmenting continuous colors into distinct color blocks, where a corresponding value is assigned based on the height of each point. This method is referred to as quantization. The quantity of quantization bits influences the precision with which we can capture the value at each sampling point. Typical audio quantization formats are 16 bits and 24 bits. A 16-bit quantization can document 65,536 variations in volume, while 24-bit quantization can capture several tens of millions. This variation in quantization depth explains why 24-bit audio provides enhanced finesse in dynamic range. Number 3. Encoding. Following quantization, we derive distinct numerical values. Nevertheless, computers cannot interpret these numbers directly, so we must transform them into binary format called encoding. The encoded signal comprises a sequence of digital combinations of 0 to 1 that computers can process. This format also facilitates straightforward storage and playback whenever needed. Once the three essential steps are completed, the analog sound signal is effectively converted into a digital sound signal. This digital representation can be conveniently stored, transmitted, and processed during conversion. PCM pulse code modulation technology functions by transforming sound vibrations in the air into a digital format. Its lossless encoding characteristics have made it very popular in various audio applications. For example, PCM encoding is commonly employed in CDs and high-definition audio formats, which is why it is often associated with high fidelity in digital sound. For 50 years, PCM technology has been the predominant encoding method for high-quality digital audio and is the most widely accepted standard today. That's all for this time. We hope you have a great time. Welcome to our Aperion University series. Here, we will introduce you to basic acoustics knowledge. We hope it will help you. If you like it, please follow us.